Hey guys, so continuing on with our daily coding problems. The problem for today is this one. So this problem was asked by Google. A Unival tree, which stands for universal value, is a tree where all nodes under it have the same value. Given the root to a binary tree, count the number of Unival subtrees. For example, the following tree has 5 Unival subtrees. Okay. Where all nodes under have the same. So I guess this one is a Unival, this one is a Unival, this one is as well, this one. So these are the 5 Unival subtrees. Okay, so I'm just going to copy this. I'll call this, create a new file. Okay. Don't need this anymore. Function count Unival tree. So I just want to think about the approach that we want to do. So right away I'm thinking of some way to traverse this tree. Every time we essentially hit a leaf, that's automatically a Unival subtree. But there also needs to be a check that checks that the left and the right child of a node is the same. Right. Okay. So obviously this, I would imagine this to be some sort of recursive solution. So this would receive in root. So I think every time you visit a valid node, you want to check its left and right node. This will probably have a global variable called count equals 0, and you basically want to increment this counter every time you visit a leaf, or you meet that condition where the left child and the right child is the same value. So within here, probably call a function called check Unival, right? And first of all, if root is not valid, actually, just so we don't confuse ourselves, I'll call this node. If it's not a valid node, obviously return if node.right and node.left. We want to count plus plus. And if node.val equals node.left and node.val equals node.right val. We also want to increment. Otherwise, we just proceed calling node.left check Unival node.right. And at the end of this, this doesn't actually need to. Yeah. And obviously we want to invoke this. We want to return count at the end, and we want to initiate the function with root. So I think that's how generally this would work. So we can think about this. Once we pass in the root, which is the 0, then this goes through, we initiate the function, passing in the root. The root then, it's checked whether or not it's not null, or if it's truly. And if it's not valid, obviously automatically return. Actually, right away, I think we need to think about the edge case where you only have just the root, where you have just 0. Yeah. But actually, I think this already handles it. So actually, maybe we don't need this. Okay. So if it's not a valid node, return. If it doesn't contain a node.right or node.left, then we increment the counter. I think there's probably, we need to return something here. But anyways, otherwise, after that, we check the node's value. If it equals to the left value and it equals to the right value, then increment the count. So actually, I don't think this is right. Because in this case, if this was 0, 0, 0, that's not a Unival subtree. Yeah. So this condition should only be the case if the left and right doesn't have a child. Yeah. You can go and, I guess, proceed doing this check where node dot left. But that's not exactly that clean. So we can think about that after. In which case, if we do need, we need to somehow relay this information back up to the root node that these are leaves, and they don't contain any children. Perhaps we can check, pass in a variable to check whether or not the node is a leaf. So I'm just thinking about going in the left subtree. In this case, when we do this, we call left first, which eventually resolves to incrementing the count by 1. And then we do the right, which eventually goes all the way down to, I would assume, this node actually. But so I think an alternative way of looking at it is that we have a recursive function that essentially checks whether or not underneath a certain node, it's a subtree. Yeah, and this check would have to check both the left subtrees. Yeah, something like if this returns true, and this returns true, then increment the count. So let me just think about how that would actually work out. So let's think about this first node. We go into the root. We pass in the root node. We're here at 1. And what we want to do is, if it doesn't have a right node and a left node, we do want to go count plus plus, and we want to return true. And let me think about, in this case, once it returns true, what we also want to do is, we don't actually need this then. What we're really trying to do is return check unival node.left and check unival node.right. Something like this, right? Where these two have to be equal, or both of these have to return true, and then we increment it. Yeah. In this case, I'm thinking if we even need to have a count. If there's no valid right node, there's no valid left node. Increment the count. Return true. Okay, let's see. Let's say we do that. This would be true. And then we go here, the right node. This would then call the left node and the right node. I think no matter what, we have to compare the value. So it's not so much returning true. We need to be returning the node's value. Returning node.value. Yeah. And this would be left value equals to and what we want to do is return node.val equals left val equals so let's think about this. So this automatically, this should still be here. And I think for this, that's what we need to do. So going this from the top again, pass in the root, nothing happens, you call the left subtree, pass in the node's left value, and what this does is, so call it again, eventually you'll get to this here, which will increment the count to 1, and it will return the node's value, and that, so basically this would equal to 1, right? And you do the same thing for the right, in which case the right will keep looping here, then going to the left, and going, which would then call left again, and this will actually resolve because there's no nodes, and you'll count 1 here, so this would be 2, and you'd return the node's value, which is 1. So this would still be 1. Then we're resolving the previous call from the call stack, which is the right value. You pass in the right value. This would similarly do the same thing. It doesn't contain a right node or a left node. And this will be a 1. In which case this resolves, and now you check whether or not node value equals to the left value, and the node value equals to the right value, which it does. So you increment it. This will now be 3. And essentially, you're at this call stack now. Okay, now I realize that this needs to return node.val. Yeah. Now I'm thinking if, however, though, if these two were not equal to each other, you don't increment the count, but you're incrementing the node value, which shouldn't be right. You should be returning something that that will ensure this doesn't get counted as a unival. So maybe we do need to pass something more than just a node value. We also need to pass that this is a unival subtree. Something like an array containing a node value, whether or not it's a subtree. When I say that, I'm talking about something like this. Oops. Let me go something like this. Yeah. And what you want to do is if node.value check.node value zero. And what you want to do is return this as well. Let's make it more simple. Let's just call it this. We call it the val 0 and the val 0. And when we do this, we just return left val 1 and right val 1. So only if this is true, then we implement the count. Otherwise, yeah, we don't do anything. So I think that resolves the issue. I think this should at least solve that problem where this ensures that if this is not a subtree, this certainly shouldn't be a subtree. So we walk back to this example. This will return the node value and any true, in which case this would then proceed to check whether or not this is a subtree. Like this will receive a 1 in true, and then once it resolves, it evaluates the right subtree. It'll go into this. It'll count this as a subtree, so 4. Actually, we should be at 5 at this point. I think I missed the count for this one. And what happens is it will go through this again. Quickly compare these two, realize that this is not a subtree. Once it returns here, then it would just return all over here. And it will eventually resolve the stack. Okay, so I think this should solve this example. Sorry guys, normally I would implement the test cases, but just for today, unfortunately I'm a little bit short on time. If I do manage to go about testing and find a solution, I'll definitely update the description. But yeah, do let me know what you guys think. Thanks for sticking around, and hopefully I'll do another problem tomorrow.